This is also 7.3 out of your textbook, factoring. This is the Algebra 2 factoring, specifically the sum and difference of cubes. So when we are doing sum and difference of cubes, we still always check for a GCF first. Notice that 27 and 8 do not have a GCF. Just to be sure, you can do 27 divided by 8. And then we know that 4 goes into 8, so you can divide by 4. Nope. And we know that 2 goes into 8. Hopefully you know that 27 is not divisible by 2. So there is no GCF. So I do have a binomial at this point. Difference, it's not a difference problem. And second of all, squares. X is not squared. So I have this little guy right here, sum and difference of cubes. Now this is actually fairly simple. It's a pattern. So in order to get my two factors, the first thing I do is I need to undo a cube, which means that I go to math, and the opposite of a cube is right there, number 3. The opposite of that is a cube root, number 4. So I'm going to take the cube root of 27. And then I need to do the same thing for 8, just to be sure everybody's a cube. And it works. So this is how this works. The cube root of 27 is 3. The cube root of x cubed would be x. I have a plus sign, so I put that. The cube root of 8 is 2. So what this means is that 3 times 3 times 3 is 27. 2 times 2 times 2. And x times x times x. So the cube root is only one of them. So that's how I get my first parenthesis. I undo the cube by cube rooting. I take the 3 and I square it. 3 times 3 is 9. Notice that 9 times 3 gets me back to 27, so that's good. I take the x and I square it, so that's x squared. X squared times x is x cubed. Then I take the 2 and I square it. 2 times 2 is 4. And 4 times 2 gives me the 8. So when I'm working this problem, I cube root everybody. Then I take everybody and I square each individual piece. Just like difference of squares, this is a plus, so this has to be a minus. And I just multiply these two together. 3x times 2, which is 6x. And now it's factored. It's finished. Again, this is just a pattern, so we're going to practice this one again. We're going to look at this problem right here. We have 8x cubed minus 125. We're going to check, sorry, you can't see that. We're going to check for a greatest common factor first. The greatest common factor is not here. 125 divided by 8 doesn't work. The next largest number that goes into 8 is 4. And hopefully you know again 2 does not. So we don't have a GCF. So we're under binomials. It is a difference problem, but notice it says of squares and that the variables are squared, but that variable is not squared, it's cubed. So I'm going to be, all the way down here under sum and difference of cubes. The only difference between these two problems, besides the numbers changing, is that I have a minus sign instead of a plus sign, but I'm still going to check. Since x is cubed, I already know 8's a cube of 2. So I got to check 125. So I'm going to go math number 4, 125, it's 5. The cube root of 8, we've already done it, it was 2. The cube root of x cubed is x. Keep the sign, and the cube root of 125 according to the calculator is 5. So my first parenthesis is always coming from undoing the cube, so I cube root. First term 2 and I square it. 2 times 2 is 4. I square the x, so that's going to be x squared. Notice that I need to square a negative 5. That means negative 5 times negative 5. A negative times a negative is always a positive. So this will always be plus. So what changes is the first parenthesis was a plus. Now my first parenthesis is a minus. And then I do the opposite sign here. It was a minus, now it's a plus. and I multiply these two together. 2x times 5 is 10x. And I am finished. So on the third example, again, I'm going to look and see 216 divided by 125. Doesn't work. Next largest number that goes into 125 would be 25. Oops, sorry, I didn't need to check that. I needed to check 216 divided by 25. That doesn't work. I know 5, but you should know 5 does not go into 216, so I am missing a GCF. This is not a difference of squares because I don't have a difference or a square. So I'm right down here. So I'm going to take the cube root of 125. And I'm going to take the cube root of 216. And they both are cubes. They worked out evenly. So that's my first parenthesis. The cube root of 125 is 5x for the x cubed. Plus the cube root of 216 is 6. And then I'm going to follow the pattern. I'm going to take the first number and square it. I'm going to take the variable and square it. 6 squared will be 36. I started with a plus, so I need to put a minus. And I'm going to multiply the two together, which is 30x. And that's my final answer. Now when you look at this problem, the first thing, again, I still always check GCF, and I noticed that 2 goes into both of those, so I'm going to take a 2 out. That should leave me with x cubed, and then 2 times 8 will be 16. When I look in here, I'm checking, that's still a binomial. It is not a difference, and x isn't squared. X is cubed, and I can see x is a cube, and we already know from doing the last, or I should say the first two problems, that 8's a cube. So I've got to keep working this problem. The GCF stays, so I'm just going to ignore the 2. It came from right there. I took it out at the beginning. So all I'm looking at is this problem. The cube root of x cubed is x, plus the cube root of 8 is 2. 2 times 2 times 2. I take my first term and I square it, so that's x squared. My second term, 2 times 2 is 4. I need the opposite sign, and I multiply these two together, so that's 2x. So I factored this guy into these two parentheses, and originally I took out a greatest common factor, so there's my final answer. Now this is partially a review from the last video with 4 terms, but I put it on here for a reason. It's going to actually hit both. So when I first start, I always check for a greatest common factor. 8 and 8 have a common factor, but 8 doesn't go into 27. The next number that goes into 8 is 4. 4 does not go in evenly to 27. And then 2, and 2 doesn't. So I don't have a greatest common factor. So for this particular problem, I don't have a binomial this time. I have a 4-term polynomial. So I'm going to be here where I'm going to group it first. So I group it up. And then I need to find the GCF of the groups. Greatest common factor should be 8x cubed. I got 3 x's in common and an 8. So 8x cubed times x will be 8x to the 4th. 8x cubed times a positive 1 will keep it 8x cubed. The sign here comes straight down, and I notice they have a 27 in common. So I would multiply by x to be 27x, and I would multiply by 1 to be 27. Notice that these two match parentheses, so that's good. So that's one of my factors, is x plus 1. My other factor is the GCFs here. So 8x cubed plus 27. Now, my job is to check both parentheses. I already did greatest common factor. So I look here. This is a binomial. It is not a difference problem, and x is not squared. It's not a cube, because there's no x cubed, so it's done, it's prime. But I look in here and I know that it's not a difference of squares because it's not a subtraction and x isn't squared. When I look here, I see a cube, and I know 8's a cube because we've already done it a bunch of times. And 27, if we don't remember, we can always check in our calculator. Math number 4, what the cube root of 27, it is a cube. So I've got to keep factoring. So the cube root of 8 is 2. Cube root of x cubed is x. Keep the sign. And the cube root of 27 is 3. And then I'm going to square 4, square, square. So square each of the 3 pieces. And then I'm going to do the opposite sign and multiply them together. Those two factors become this 1. This factor, x plus 1, hasn't gone anywhere, so I have to keep it. And that is my final answer. This was prime, so I kept it, but this continued to factor because it was the sum of cubes. And that's how you factor sum or difference of cubes.